Whee! This looks fun. Okay. Hey folks, I hope you're all doing well. And let's talk a little bit about C++. Okay, so in the previous video we talked about output, talked about printf and the C++ equivalent cout, about escape sequences, how we gotta be extremely meticulous, like insanely so when we write our programs in order for them to actually function the way that we want. So, yeah, this is normally where I'd have a close your notebooks, don't take notes on this, just absorb it kind of thing. We've talked about this already, what is memory? So when people talk about memory, they often think in terms of RAM, this guy, or random access memory. The stuff that if you say, I'm going to upgrade my memory, you're usually talking about your RAM. But there's also hard disks. This is also memory. So either your spinning disk style hard drives or your solid state drives in newer machines, doesn't matter. The long-term storage on your machine, when you save a file, this is where it goes. But when you read a file, part of it, well, as much of it as it can, gets transferred into this. And there's a reason for that. This short-term memory, the reason it exists is because it's way faster than this guy, way faster than our hard disks. And we want to access our data in the fastest way possible. So even though this guy is really fast, it's what we call volatile memory, meaning when you turn your computer off, everything that's in here goes away. It disappears. And this is our persistent memory. When we write stuff to the hard drive, we want it to stick around. As long as that hard drive's working, your data is going to stay encoded on this little spinny disk. There's another kind of memory that you don't hear people talk too much about because it's pretty much abstracted away from even the programmer most of the time, and that is super short-term memory called cache on your CPU. It's also volatile memory. Imagine RAM, but much, much faster and much, much smaller. So what ends up happening is when you're when you're running your code, you save it here, it gets compiled here, then you run it, and it gets copied into memory. And some smaller component of that then gets copied into your CPU cache. And then when that finishes executing, it says, okay, give me what's left of your program or your whatever's being processed, and moves it back into your CPU cache. That's super, super short, extremely oversimplified version of what's happening. But remember, our memory is just a box that we can put data into. Now, you've seen me look at this example in class already. You can think of each of those little memory chips as just a bunch of little boxes, all with a number that's their address. So if you say, I want to write something in box 07, you'll access box 07 and you can write your data there, or you can read data from that. Yeah, so like I said, everything in memory has a numerical address. And really, when we start talking about pointers, that's what we're talking about. A pointer really isn't anything magical. It's just knowing the address in memory where your data is stored. Okay. And our variables are ways of, giving these human readable names that we can deal with. So yeah, we've talked about this before. And yeah, everything is data, everything on your machine. Your music, your videos, your documents, this, that, and the other. It's all just series of ones and zeros. Yeah, when your programs aren't running, they're stored in your long-term memory. But when your programs are actually executing, as much of them as possible is copied into RAM and your CPU cache. So this is sort of the pathway these guys follow when you're executing your code. So you run a program, data associated with it's going to be stored on your hard drive. Portions of it copied to memory, smaller portions of it copied to your CPU cache. And like I said, this is an oversimplification, and we talked a little bit more about this in class, so I'm not too worried about you understanding this model. And again, it's stored as ons and offs, ones and zeros, trues and false in memory. Absolutely everything that you have on your computer is stored in this way. And, it seems kind of weird to think of it that way, but, if you think of it, the entire universe is composed of three numbers, -1, 0, and +1, or at least, as we point out here, at least the important bits. And there are physicists who will disagree with me, and that's okay. But for the most part, what we interact with on a daily basis is made up of 0, -1, and +1. And those are just representations, that we can use to encode literally everything in existence. Okay. So data in memory has meaning. So it's all about the way that you encode them and the way you store them. For instance, we store colors using a series of numbers representing reds, greens, and blues. We can encode decimal numbers, using ones and zeros for like the numbers of ones, numbers of twos, numbers of fours, numbers of eights, numbers of 16s, and numbers of 32s that add together to make the number we're trying to represent. And similarly, we can use this same encoding scheme to give every number, letter, and character a numeric value that we can then use to represent the alphabet. So, for instance, this is representation of my name. Now, most of you are somewhat aware of this already. We've got our integer type variables, which are whole numbers, negative infinity through positive infinity effectively, but like 1, 2, 3, 4, 5, 6, 7. Then we have our floating point, or our double numbers. They're floating point representations of fractional numbers, where we can represent a whole portion plus some sort of fractional portion. And our characters. Yeah, you guys seen this before. Declaring an int in C or C++ looks exactly the same. So you make an integer variable this way. What you're doing is you're saying, I want to call a box in memory the name X. And what I want to store in that box is an integer value. And same way if you want to make a floating point variable. You say, I want to get some memory, and I want to make sure that I store float type data there. And I want to give it the human readable name average. Average just redirects us to some funky looking memory address out here, in the ether on your computer. But the variable name you give it is just the human readable label. What's sitting behind it is a real actual address in memory. Characters, same way. Now you guys have been working a lot with strings lately, and you're probably noticing the pattern. If you want to make a string type, you say, I want a string, and then you give it the name of the string that you want to use. So yeah, this is called declaring your variables. Often you do this early in your program, towards the top of your functions, but you can do it like older implementations of C-like programming languages usually required you to implement these before you actually wrote any other code in your program. But with C and C++, you can actually declare variables pretty much anywhere inside your program that you need them. So the first bit here is our data type we've talked about, and then this is our human readable name. So when you declare these guys, you don't actually know where in memory they're going to go. Your computer's going to figure out where there's enough space in memory to fit whatever it is you're looking for, or whatever it is you're wanting to store in memory. So you don't know if your integer is going to be stored here or here or here or wherever. So this is why this is mostly invisible to even the programmer, is the computer is going to figure out where in memory they go. But now here's the catch. Computers are stupid. They're really, really dumb, and they're sloppy. And memory is just full of garbage. Even when you turn your computer on, there's still going to be little fragments of data left in memory that didn't completely dissolve into the ether from the last time it was running. There could be stray voltages in there, giving you representations in memory that aren't realistic. It's computers are messy. We like to think of them as nice and clean and straightforward, but they're not. So when you declare these guys, your computer goes out and grabs a hunk of memory, and it doesn't know or really care what used to be there. So if you try to reference these guys, you might actually get garbage out. So to avoid that, oh, and by the way, these are called dangling variables. What you got to do is, if you want to make sure that everything's nice and clean in your program, initialize everything. And usually the best way to do that is, if you have an integer, initialize it to 0. If you have a float or a double, initialize it to 0.0. If you have a character, initialize it to the null character. /0 is called the null character. It's a special character that means nothing is here. And, you can do it like this after you've already did your declarations somewhere up higher in your program. But it's probably just good practice. Just go ahead and when you initialize them, just go ahead and initialize them to something 0-ish. Unless you know exactly what you want. Because sometimes you get something like pi that you want initialized. Initialized to something very specific. Okay, this was an example that we would do in class. You want to try to pick names that make sense for your variables. I've seen people name their variables Joe, Sue, and Tom, and believe me, that is the least helpful thing you can name a variable. Name them things that make sense. Like if you're calculating average, name them AVG or average or something like that. Just make sure that the names make sense. And there are some things that you can't call variables, and these are reserved words in the programming language. For instance, these are examples of reserved words that you can't name a variable. Okay, for outputting variables of different types, like I said, you'll probably run into printf at some point in your career if you're doing any kind of C or C++ development, even if you're using C++. You're going to find somebody using printfs at some point. To display variables inside your output strings, you have to use something called a conversion specifier. So you essentially write out the string that you want to show on the screen, and then where you want the variable to go, you put a $D for an integer, or a $F for a float, or $C for a character, so on and so forth. And these are the common ones you're going to be seeing. If you're dealing with C++ and everyone's playing nice and they're all using the standard input and standard output like cout and cin, you don't have to worry about that. You just use your cout less than your variable name, and it figures out what it is and displays it in the appropriate way. So one wonderful thing that C++ makes easier. Here's some code examples you can play with if you want to kind of give you an idea of how this works. Okay, and this isn't your homework because this class is like a decade old or something now. So yeah, there's a little bit on dealing with variables. And again, this is not an official lecture. It's just a quick, simple refresher tutorial I'm doing. Again, not supporting this. This isn't officially part of the class, just something I'm putting together to kind of help you guys out. Okay, so hope you're all doing well, staying happy, healthy, and safe, and I will see you in class.